general relativity step by step. Now then, I'm trying to find this transformation matrix called the Lorentz transformation matrix, and so far I've identified these two terms here, gamma and beta gamma, and I need to find out what B and D are, and I haven't been able to find out what they are. So what I'm going to do is I'm going to choose, I can choose anything I like for a t and x. So here's my unbarred coordinates, that's a t, and what I'm going to do is I'm going to get my laser light and I'm going to go along there, and so I'm just going to choose, go back to black, tx, the unbarred coordinate system 1, 1. So it's a null geodesic, a null path. So t bar x bar equals gamma b beta gamma d 1, 1, which equals gamma plus b beta gamma plus d. There it is. So what that tells me, or what I can do now, is I know that delta s squared, the squared interval, is delta s bar squared. So that tells me that minus t squared plus x squared equals minus t bar squared plus x bar squared. So that tells me that minus 1 squared plus 1 squared, which is of course equal to 0, equals, because it's t and x, minus t bar squared from here, gamma plus b squared, so it's minus that, plus beta gamma plus d all squared. So that tells me that gamma plus b squared equals beta gamma plus d all squared. Right, that's a complicated equation because I've got two sort of squared terms here. It's quite difficult to deal with. So what I'm going to do is I'm going to choose the laser light going the other way, and so that corresponds to t equals 1 but x equals minus 1. And you'll see why I want to do that in a minute. I want to be honest here and say that this artifice of looking at the laser light going the other way took me some considerable time to come up with it. It's not obvious. So let's just draw it in anyway. So we've got t bar x bar, this is for the leftward, equals gamma b gamma beta d times t and x. So t bar x bar equals, oh no, I'm going to substitute it in. I've got 1 and minus 1 there. So that says that gamma minus b and beta gamma minus d. Right? Yeah. Okay, so when I apply this reasoning about the s squared term, now we have gamma minus b squared equals beta gamma minus d all squared. Because I've got this, because I've got the sign changing here. Right. So what I'm going to do is to multiply these things out. We've got gamma squared plus 2 gamma b plus b squared equals beta squared gamma squared plus 2 beta gamma d plus d squared. That's this equation here. This equation goes to gamma squared minus 2 gamma b plus b squared equals beta squared gamma squared, the sign's changed, plus d squared. And of course I'm going to subtract one from the other and see what we get. 4 gamma b, everything else cancels. Actually I like cancelling. Cancel, 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 cancel. Equals 4 beta gamma d. So that tells me that cancelling by 4 gamma, b equals gamma beta d. There we go. So now, here's my equation. We've got gamma b beta gamma d, gamma b beta gamma d. Now I can write this. Gamma beta d beta gamma d. And that's my Lorentz transform. See, I'm gradually putting the handcuffs on this guy. When I started out, it was just A, B, C, D. And I've been using slightly different physical arguments all along. Still don't know what D is, and I'll do that in the next screencast. So I'm going to stop there, and I'll find out what D is on the next one. But see, we've only got 1 degree of freedom. When we started out, we had 1, 2, 3, 4 unknowns. That's supposed to be a D. And now I've only got 1, and I can fill that in. I'll do that one on the next screencast. Stop there. Stop, 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 stop.